Hi, I'm Tom Burke, the Associate Dean for Public Health Practice here at the Johns Hopkins Bloomberg School of Public Health. And welcome to Public Health on the Inside, your inside look into the world of public health. So have you had your flu shot? I hope so. Many people really don't understand the public health impact of flu. But in 1918 and 1919, the great Spanish flu pandemic wiped out, they think, between 50 and 100 million people worldwide. Now, fortunately, we haven't seen the likes of that epidemic, but we are seeing things change with respiratory viruses. Today, I want to introduce you to my colleague, Dr. Andrew Pecos. Andy is an associate professor here at the Bloomberg School in our Department of Molecular Microbiology and Immunology, and an influenza expert whose research focuses on understanding how viruses cause respiratory disease in humans, and most importantly, identifying ways to prevent and treat these infections. Andy has been investigating the basic replication and disease mechanisms of several respiratory viruses: influenza A, SARS, hantaviruses, and most recently, H7N9. Andy, welcome to Public Health on the Inside.
Thanks very much for having me.
Well, when flu season rolls around, you're a busy person. I think I first met you in 2009 when we were grappling with the emergence of H1N1. This has been a busy time these past few years.
Yes, it has. We've had a pandemic in 2009. Previous to that, we've had these outbreaks of H5N1 avian influenza, which has been with us for nearly 10 years now. And as you mentioned, most recently now we're having these outbreaks of H7N9 in China, as well as this new coronavirus that's been present in Saudi Arabia. So there's been a flurry of activity with respiratory viruses over the past few years.
Andy, I remember when my mother heard about the emergence of bird flu, she told me she wasn't going to eat chicken anymore. And people really sometimes don't understand this when the press talks about avian influenza and the emergence of a scary new virus with a high fatality rate. Can you put that in perspective for us? It really hasn't been a disease we've seen here in the U.S.
Right. So right now, this is a potential threat, but when it comes to an immediate concerns of the U.S. population, neither the H7N9 nor the H5N1 outbreaks should be of day in, day out concern to the U.S. general public. All the cases of these infections are from people coming in contact with infected poultry. The virus is not being spread from person to person. And the infected poultry are really in places where farming practices are very, very different from that of the U.S., where there are live poultry markets and exposure of humans to infected poultry is really maximized. Now, we are concerned about the H7N9 virus becoming a pandemic, and that's why the U.S. has garnered its public health resources to address the issue. Right now, there should be no impact in terms of how a U.S. resident is going about their daily activity.
No impact on our food supply, no real concerns about chicken and other things in our food supply right now.
When it comes to the U.S. population, there should be no concerns about avian influenza in poultry here in the U.S.
I'd like to ask you about the code numbers, H something, N something. This is a way that you identify the viruses, but what does this mean to the layperson?
What's important to know about these numbers that we associate with the H, the hemagglutinin, and the N, the neuraminidase gene, is they're related to the immune response that one generates against one particular H protein. Humans have been infected with either H1s, H2s, or H3s over the past 100 years or so. So against all three of those influenza subtypes, there's some level of pre-existing immunity in the human population. When we come to hemagglutinins of different numbers, such as the H7, H7s have never really infected humans previously, and therefore virtually the entire human population is susceptible to infection. In other words, there is no pre-existing immunity in the human population to an H7 virus. And that is one of the primary requirements of a pandemic, is that the human population has to be much more susceptible to infection with this strain of flu. So what the H7 is in terms of a concern to the human population is the fact that it represents one of the 10 varieties of influenza A virus strains to which humans don't have a pre-existing immunity to, and therefore the pandemic threat is higher with those types of viruses.
And this is why we're constantly working on new vaccines, and it's important for people to get their annual flu shot.
Absolutely. We know very well how to make influenza vaccines against H1, H2, and H3s because that's what we've been working with in laboratories for the past 50 years. What we want to do is apply those same techniques now to these new influenza virus strains and verify before they're needed that these vaccines can be made and are able to induce strong immune responses.
There's many, many things coming together. Early detection is really critical, countering a potential pandemic. Can you talk about the role of the laboratory?
The H7N9 outbreak right now is a perfect example of how basic research and molecular epidemiology really can impact a disease at an early stage. In previous years, we would have had no understanding of what's causing these outbreaks. It would have probably taken weeks for us to identify the pathogen. And by the time we could muster our public health resources to try to intervene, the infection probably would have spread and gone outside the limited geographical region that it's in right now. With our advances in terms of molecular techniques to detect influenza virus strains and to track where they're coming from, we've been able to relatively quickly come up with a very detailed understanding of the virus that's causing these H7N9 outbreaks, the numbers of cases and where they're occurring, and the epidemiological track of finding the source animal to try to limit the interactions between those animal reservoirs and humans and minimize the number of cases that are occurring.
H7N9 is a uniquely challenging one, according to some folks. It's very interesting, the number of cases in China, but there appears to have been some spread. So this is not behaving like a normal bird flu.
No, it's not. It poses particular challenge because in humans, right now it has about a 30% mortality rate. So 30% of the infected individuals are dying, and a vast majority of the infected individuals are hospitalized. So in humans, it's a very severe disease. But it turns out that in poultry, the infection causes virtually no disease symptoms whatsoever. So it's incredibly difficult to track where the virus is based on looking for sick animals or looking for disease in poultry. So what that means is you need some sort of molecular techniques to go into those animal farms, the live poultry markets, and try to find which are the animals that are harboring the virus and try to use that information to try to backtrack and eliminate the source of the virus infection. It's been occurring over hundreds of kilometer areas in China, so it's probably not a very limited exposure. This virus is entering the food chain or the agricultural system someplace at a very basic area and spreading in that geographic region of China.
And if the chickens aren't sick, the farmers have no clue. They might have an epidemic in their flocks and yet no sign.
Absolutely, and this is a big difference between the H7N9 outbreak and the H5N1 outbreak, which has been occurring throughout the world now. In that case, the H5N1 virus does cause disease in poultry, so it's relatively easy to find out where the virus is because you simply keep track of the sick poultry that's there. Here, this virus is a stealth virus. It doesn't seem to be giving us the signals in its animal reservoir that it's there, which makes it very difficult to then put in place good public health measures to limit interaction with the infected animals.
And I know that our dean recently visited China, and it seems that surveillance and communication with China about these emerging infections has really improved.
It's been very, very reassuring to see how forthcoming the Chinese authorities have been with their information, to see the number of resources that they've applied to this problem. And with the daily updates and monitoring for this disease, it really is something that is on their radar screen and is being very, very aggressively addressed by the Chinese government.
Now, flu doesn't affect everyone the same way, and I'd like to ask you a little bit about who's most susceptible to flu.
All of us can get what we call a standard flu disease, but certainly there are populations that are more prone to get very severe disease from influenza. Primarily, those are the very young, under the age of 7 or 8, and those over the age of 60 or so. There are also some other populations that are susceptible to severe influenza disease. Pregnant women are one of them. A number of metabolic disorders can lead to increased susceptibility to influenza. And So it's not a disease, it's a disease that certainly can affect all the populations, but it can be particularly severe in a number of critical populations.
So I'd like to take you back to 2009 and H1N1 when we first really met. And I know you were a laboratory scientist who became a tremendous resource to the practice community right here with DHMH and part of our communication efforts and decision making. We had to make tough decisions. We had an emerging flu with no vaccine. And I'd like to talk a little bit about what we do when there's a vaccine shortage and how we spring into action in public health.
I think that the important issue that we always have to discuss when there is a vaccine shortage is how best to utilize those resources. Do we use them to protect populations? Do we try to identify the populations that are most at risk of spreading the disease? Or do we target the populations, for instance, that are most susceptible to severe disease? And those are ongoing discussions. Every influenza pandemic has had slightly different characteristics. And so the approaches, the public health approaches to an influenza pandemic have to be a little bit different and based on the properties of that virus. And that's where I think basic science investigators really can contribute to the public health discussion, because we're the ones that know the genetic signatures of this virus, the properties of this virus, and particularly at early stages of an outbreak or a pandemic, that's the information that we can use to glean the potential threat of a virus such as 2009 H1N1 or now the H7N9 virus to the human population.
Great. Andy, I want to ask you a more personal question. You obviously love your work, and public health is fun for you. People get excited by working with you and can feel your enthusiasm. Tell me about what's most enjoyable about your work.
I think it really is not only looking at a virus which is fascinating in terms of the intricacies in which it interacts with the cell, with its host. Influenza has 8 genes, and it has about 10 to 12 proteins, depending on the strain that you're looking at. And yet it can infect an organism as complex as a human and cause such a severe disease at the same time as it's multiplying itself and preparing itself to be transmitted to the next individual. So the intricacies of working on influenza from the molecular basis up to the public health significance are all really interrelated. And so going into the laboratory, doing experiments, learning about the basic biology, all sort of funnels up into public health, into our public health knowledge base and our understanding of this virus. And it's that connection that is really the fascinating one to me. The fact that we can do molecular work in a laboratory settings and that it has very, very direct relevance to human disease and public health is what really is most exciting to me.
Andy, I want to thank you for being here today to share your knowledge. You're also a tremendous translator of the science so that folks can understand it and we can move toward prevention. Thank you for participating here, and a special thanks to our listeners. Until next time, this is Public Health on the Inside.